In World War II, water was as destructive as enemy fire. Rain flooded trenches, soaked uniforms, rotted equipment, and turned shelters into cold traps. Modern synthetic waterproofing barely existed, and rubberized gear was heavy, noisy, and prone to cracking in cold weather. Yet soldiers across multiple fronts relied on a simple, reliable water-blocking method made almost entirely from natural fibers. It was not fully waterproof in the modern sense, but it worked consistently where plastics failed. The secret was not repelling water completely, but controlling how water moved, spread, and drained. That understanding made the difference between damp discomfort and operational failure. Why World War II environments demanded smarter water control. European forests, Pacific jungles, and coastal battlefields shared one problem: persistent moisture. Rain rarely fell once and stopped. It lingered, soaked into everything, and returned daily. Soldiers quickly learned that sealing water out entirely was unrealistic. Condensation from body heat would soak gear from the inside, even if rain stayed out. What they needed was a material system that slowed water entry, redirected it, and allowed internal moisture to escape. This requirement, you see, led to the widespread use of treated natural fibre fabrics rather than impermeable barriers. Now, how natural fibres behaved was quite different from rubber and those early plastics. Natural fibres such as cotton, linen, jute and hemp actually swell when exposed to moisture. World War II engineers and quartermasters, they understood this property and used it quite intentionally. When tightly woven and properly treated, these fibres expanded just enough to close microscopic gaps in the fabric. Instead of cracking or stiffening, the material became denser under rain. This self-tightening effect reduced water penetration while still remaining flexible and quiet, even in cold conditions. So let's talk about how the water-blocking treatment actually worked. You see, the fabric itself was only part of the system. The real trick, well, that was in the treatment. Natural fibre sheets were impregnated with waxes, oils, or fatty compounds. These came from beeswax, paraffin, linseed oil, and sometimes even animal fats. The treatment didn't coat the fabric like paint, not at all. Instead, it soaked in. This meant the fibres became water-resistant without losing their breathability. Rain would roll off the surface, but vapour could still pass outward, albeit slowly. This clever approach prevented internal condensation, which was the failure point of most early waterproof materials. Now, let's talk about why canvas ponchos and shelter halves really outperformed tarps. World War II shelter halves and ponchos, you know, those made from treated cotton canvas, are the clearest example of this. When pitched correctly, rainwater would follow the fabric downward and away, instead of pooling right on top. The fabric, well, it sagged just a bit when wet, which actually tightened the weave density and improved its resistance. On the other hand, tarps made from rubberized or early synthetic materials, they either flapped violently in the wind, collected water in big puddles, or simply split under stress. Now, here's how soldiers used fibre layering to block water effectively. The method relied on layers, not just a single barrier. A treated canvas outer layer was always facing the rain, and beneath it an airspace allowed moisture to evaporate away. Clothing layers underneath stayed drier than expected because water never reached them directly. In dugouts and shelters, soldiers hung treated fabric at angles rather than vertically, ensuring gravity-assisted drainage. This approach turned water from an enemy into a managed variable. Why rope and stitching mattered as much as fabric. Natural fibre ropes, often made of hemp or sisal, swelled when wet, tightening knots and seams. This prevented gaps from opening at stress points. Modern synthetic ropes do the opposite, loosening under moisture. World War II shelters stayed sealed because every component reacted to water in the same direction. Seams tightened, ropes held, fabric closed. The system improved as conditions worsened. How this trick was applied beyond shelters. The same principle appeared in packs, ground sheets and vehicle covers. Canvas pack covers shed rain while allowing trapped moisture to escape. Ground sheets placed beneath bedding blocked upward seepage while, still breathing enough to prevent pooling. Even sandbags relied on natural fibre swelling to create tight, water-resistant walls once exposed to rain. The material choice was deliberate, not accidental. How modern users can apply this knowledge practically. This World War II method, interestingly enough, remains useful today. Waxed canvas, oil-treated cotton and tightly woven natural fibre fabrics can be used for tarps, ground cloths and gear covers. The steps remain simple. First, choose a dense fabric. Then apply wax or oil evenly using low heat. It's important to allow it to soak in, rather than just forming a surface film. Always pitch the fabric at angles, never flat. And maintain airflow beneath the layers. This approach works for long-term outdoor use, emergency shelters, and, environments where noise, durability and repairability really matter. So, why did this technique fade after the war? Well, post-war manufacturing favoured cheap plastics and disposable materials. Breathability and longevity, honestly, were sacrificed for convenience. Natural fibre treatment required maintenance and understanding, which did not fit mass consumer markets. Yet the World War II water-blocking method never failed, because it aligned with physics rather than trying to overpower it. Why this trick still matters. Water management remains the most overlooked aspect of survival and shelter design. Fully waterproof systems often fail in a catastrophic way. On the other hand, controlled water systems tend to degrade gradually and, predictably. The World War II natural fibre method, it accepted that water would arrive and actually designed materials to respond intelligently. That is why it succeeded in jungles, snow and, even in constant rain. This was not a miracle material. It was, disciplined material science, guided by experience under pressure. Soldiers trusted it because it worked when everything else soaked through. If this exploration of World War II field engineering added real value to your understanding of historical survival knowledge, support in the beginning by subscribing, sharing this episode, and helping preserve practical techniques that remain relevant long after the war that forged them.